Thanks for having me, and thanks for the invite to that really special 100th Datageeks meetup. So I actually was asked to maybe iterate on the keynote that I did before. Similar to Kareem, I actually took like one personal use case and I expanded it a little bit throughout the time. And I specifically like that we talk about these personal use cases and how we solve problems with technology. And I think that not only inspires us, and all these showcases also us that we can basically learn something in private, find a solution, maybe that finds their way back to work. So we educate ourselves actually having fun at the same time. So with that, I have a couple of use cases that I brought today. What I'm doing besides the use cases you're going to see in a second, I'm leading a customer engineering team at Google that basically works on AI and machine learning problems here in Germany. And as you might have guessed, there are like a lot of big customers and topics out there. So our team is like actually expanding rapidly. And there's a lot of work to do, specifically with the realm of AI coming pretty much or knocking on the door every day. So I brought actually a topic that reaches from Gemini to Genie. And these are two models that I haven't heard of as of today. Not Allianz hasn't mentioned them. So maybe get rid of the OCR and implement Gemini. That might work better. But just like as a brief explanation, I will go through the technology in just a bit, but also like highlight what really shined for me and was a creative solution for some of the problems. And the problems that we're going to talk about are all really personal related. I'm not from Bavaria. And this was a huge challenge when I moved here about 2 years ago. I actually was told by my boss to get like the appropriate Lederhosen for the Oktoberfest because apparently people like that festival. I never touched on it beforehand, and I didn't know that buying Lederhosen can be such a complex journey. But I will show you like really cool data points and how to also, similar to the Allianz using, how to automate that process and how to be trendy not only for this year, also for next year, and maybe also to set the trend. And therefore, we're going to use a couple of Google models. We're going to use the data richness that we do have and that you also might have access to. Holy moly. OK, now everybody's awake. Maybe that's a ping that just came through. So anyway, that's the first one. The second one, by the way, I don't have a timer. And I've like, similar to Kareem, I have like too many slides. And you let me know. OK, good. But OK, maybe. OK. So regarding running, I also have a running example. So I'm a triathlete, or at least I try to. I'm really passionate about that sport. The general essence is I really suck at one of those 3 sports, and that's running. And I do actually have a coach that told me how to improve running, only basically showing me how professional runners are doing their job. And I try to solve that and make this quantifiable, showing you a running example. The third example is actually really close to my heart. It's AlphaFold. So for those of you who captured this actually like a year ago that AlphaFold 2 actually won the Nobel Prize. And we had like a good basically journey in Munich, also working with like structure prediction. I want to show you some insights there that really inspired me. And last but not least, for those of you who are gamers or like robots, I want to showcase you like some glimpses in Genie 3. Which is, in my opinion, one of the coolest things that happened this year. But just to basically mention another technology that will maybe affect your future quite rapidly. And if we have time, maybe we can basically talk a little bit about cloud space, which is also like a really cool area where we can all come together. Maybe also for another meetup, Thorsten, we can use that space as well. So, but yeah, here we go. Thank you. So, but first off, this is a funny Google story, actually. It gives you a little bit of a background where we actually come from and how Google got to that point that we are currently at. So as it started, I came to Google twice. I just left and tried to found Google 2.0. It didn't work out quite well, so I came back. But the funny thing is actually we started as a search engine, and it was a research project in 1995, and you might know that. And it was actually, and this is like regarding the colors were actually inspired by Lego bricks. So I actually planted a lot of Easter eggs in that keynote here. By the way, you're the first people that actually hear that keynote because it's never been presented. So I hope it's at least like kind of like insightful where where things are standing, where we're coming from. So one of the servers you actually see on the right-hand side, it's now in a museum, and it's one of the original servers built out of Lego bricks. So that was 1998. Some of you remember the search engines back then. Any idea? Alta Vista here? Lycos, usually you don't hear that one. So we had Yahoo, was actually the market leader back then. We had like Alta Vista, we had Excite, for those of you who touched on that. We had Lycos, we had Infosec, and somewhere there was Google. So nowadays it's still, I would say, like as a search engine, our main driver of revenue in business. But in 2008, actually cloud popped up alongside of a lot of other bets and a lot of other departments. So on the left-hand side, basically you can see Alphabet is the whole conglomerate of like companies that also have a lot of, like I would say, machine learning close technologies. You can think of the self-driving cars, or you can Project Wing, like aircraft, I was told, don't call them drones, aircraft that can deliver cappuccino, for example, from office to office. So a lot of cool companies actually that work together and use the technology and the underlying architecture. And if you bring this all together, actually we have this one Google approach. And the Lederhosen example, for example, is one of those approaches where we use data that resides in search, in GBO, and basically use it as in the cloud where I'm currently working to solve a problem. So this is like a little bit more deep dive. I think we can skip this. The funny thing is now I had on every slide, I had that Google logo with these color combinations. So this is our main hiring criteria, if you can solve that. So is anybody brave enough? By the way, I was told that it's like somewhere on my laptop, but anybody has any clue? Because that's quite a tough challenge. Even for Googlers, it's like close to impossible to solve this right off the bat. I hear 12. I hear 12, and 12 is correct. That's good. That's really good. For the person that was celebrating, do you know the answer to, what's that? Who gets the job? Here we go. Give me your contact details later. So a little more advanced question might be this. Considering the time frame of October 1st, or date, 1998, the same question. Anybody has a clue now? So there was that 1 month, actually, in Google history where the G was green colored. So this is just another Easter egg, but this is quite tough to answer, obviously. And it's not only for Googlers tough, also might be tough for some of you, even if you have seen the logo like for the last, pretty much 27 years. So I thought maybe we can, like, using AI technology, make this a little bit easier and use some of the agentic stack to like solve that and identify whether logos are right and wrong. So all of these projects that you're going to see right now, these are basically weekend projects. And you might have heard of like the Google stack. Just like to remind ourselves, we just like launched like an agent platform. This is essentially where you put all your agents on. This is called Gemini Enterprise, which just launched last week. The idea here is we want to basically build a couple of agents that can give a better answer to that question, or even faster than we can. And I'm going to show you in a sec how we do that. So for example, Agent Development Kit, this is like an SDK specifically for agents. It's super easy to use, and I highly recommend checking it out later on for everything that is going in the direction of like basically agentic workflows, rather than basically pinpointing your LMMs and then function calling together. So just keep that in mind. It's a really cool tool, and it sits like right in between like in the no-code and the do-it-yourself level. So at the very, basically it's a little bit less complex than LangChain. And LangGraph obviously depends on LangChain, and the ADK is like sitting on top. It gives you UI just like to play around with. And that's what we did for the first example, just like as an intro, to solve that question. So basically you can build a very simple agent on ADK and ask it which logo is correct. And when you basically feed this in, this doesn't ultimately work, because the larger language models, sometimes they are not as capable as we think in the current stage, specifically if you hand them 12 logos at a time. So the very, very easy approach to that is actually, you do nowadays have like parent agents that can call various tools, right? And two of those tools are like also different agents. They could be anything. They could be data sets. They could be like specific APIs. And this example is just like two other tools. So we have one root agent that we feed the image to, and two other agents, one of which can identify the location and can count the logos in the image, and one of which checks the color combination. If you don't do that by default, whether it's ChatGPT or Gemini, they just start tripping, and the counting goes off, and they just like say every other logo might be correct because they don't getting the numbers or the colors right. Obviously, you can extend MCP there. I'm going to skip this for now. Essentially, if you do that and feed it into an ADK, it gives you the correct output for that example. And I just photoshopped this basically. This very picture that you see here and just exchange the colors. And when I fed in the second logo, I actually found that two logos are correct. So we have like the same logo on 1 and 3, which I didn't even notice, but feeding this to the agent, it actually tells you right away. So this is like a little bit about the Google history, like a sort of energizer, but now getting to the very hard topics. How to buy the perfect, nicest lederhosen you can think of. So in a nutshell, it's a data problem and an AI problem. So at Google, we do have a lot of search queries, right? And the idea is basically back then to how can we make money out of it? It's pretty much when you tell advertisers on Black Friday, cat food or dog food is rising because they want to put their marketing campaign on the topics or on the categories that are interested to them. So the thing is that we do have let's call it a huge data warehouse of search queries, and they might be a little bit more complex than you expect because every one of us searches differently. That's the first thing. The other thing is like a lot of the search queries we see on a daily basis we have never seen before. So it's about 15% of the searches we never seen before. So it's quite difficult to basically do a rule-based system in that case. It can be like a new car model, a new song from Taylor Swift, whatever. So it's like quite complex to do this rule-based. So we have a large, not a large language model in this case, but we had a very capable machine learning model that can identify thousands and thousands of product and service categories. We want to know the ones from the lederhosen. And within those, we want to find what's really appealing in those lederhosen. In addition, we combine this now in the talk with a forecasting model because we don't want to know what's trending right now. We want to know what's trending at the Oktoberfest. So in the 2-week time frame that we are there really legit and look kind of beautiful. And the idea is like, how do we look then? And giving the state-of-the-art diffusion models, we have like a couple at Google. One is called Imagine 4, one out of Banana, if you've like touched on that one. Or Vio for basically making videos. And we can throw all the findings from the searches, including your personal face in that model, and it generates how you will look like if you're trendy on the Oktoberfest or at the Oktoberfest time. So I think the problem appeals not only to lederhosen, it's like pretty much for every other industry. It's like a demand sensing or assortment planning idea. So I skipped this in a matter of time. What I was told when I got here is that these trends are changing rapidly, and it's kind of true not only on a yearly basis. When you ever touched on one of those, I basically went there, it's called Moser Trachten. It's like a huge warehouse, like a football field size, and they have like everything regarding lederhosen. So it's like, and it was kind of tough to make a decision there. So I got back, this is when I was there. And I was picking up how you said this, the checkered shirts, which I really liked, and the lady was telling me, no, you don't do that. No, it's not trending anymore. But I just know this as a tourist, but I was told not to get that. So I used data for solving that problem. I scraped pretty much everything, a search query that holds lederhosen from YouTube. YouTube is, by the way, the second largest search engine on Earth, and everything from search. So what came out is like, I'm not the only person searching lederhosen online, so it's like 17 million in Germany alone, and there's like this 2-week time frame in a year. So this is a chart from 2004 to 2024, where you can see that it's peaking. And ideally, if you want to sell them, you do want to sell the cool ones, and you want to have them in stock, and don't want to overstock on the boring ones. The interesting, I just like to pinpoint, the interesting cool thing is like within those search queries, there are like clues what might be interested for people or what people are searching for. Just one note, and this is why, while this real-time data is so cool, because we can basically see what people are searching on the day, like on a specific zip code, for example, or a specific time. Oh, by the way, we're only searching creepy stuff when you really look into those numbers and into those queries. But it's like important to say you don't want to rely on historic data by itself only alone. So it's really, really good to have like also sorts of time frames. So how is it built together? So this is pretty much also an agent system. So we have a lot of search data. We have like two agents. One is a data insights agent. It's a pre-built agent that can basically analyze data on BigQuery. BigQuery is the data warehouse that we do have. By that note, BigQuery also holds public data set of search data. So whenever you want to touch on a similar example like that, you can just go on BigQuery. Google is not a data seller, so basically every advertiser gets those for free. You can use these data sets for free. And in my opinion, they are much more valuable than any other data set out there, or could predict the stock market better than any financial analyst. This is my personal opinion because they are so rich in insights and clues what they got. So we have the data on BigQuery regarding the searches. We have a time series model. It's just like for the sake of easiness, just an ARIMA model. And we have a creative agent that basically uses the time series data to create like the output later on. So this is how the data looks like. So plain and simple search queries. Where can I buy lederhosen and the absolute search volume attached to it. So a lot of it is in English, by the way. So there are lots of tourists, I guess, in the city. And what you can do basically with the data insights agent, you don't need to train like models from scratch anymore, because you can just tell them in natural language that you should train a k-means clustering models to identify the categories that are important and to use the time series model. When you do that all together, you get like 6 clusters out of it, if you basically tell the k-means to produce 6 clusters. These are the important clusters that was told to me by the model. It's just the size of the lederhosen, the color, the fit, the material, the pattern, and the shirt, which I totally neglected at first. And when you run this through the time series forecast, you get like the trends for the Oktoberfest. This was in 2024, so it's like a year old now, but it was short, brown, slim fit, deerskin and a floral pattern, and a white shirt. The cool thing is like the creative agent just picks those, and here's like some sales slide. You can basically feed my image into it like at Moser Trachten, and it gets you the idea how you would look like when you're like trending like the Oktoberfest. So you cannot see that in the picture, but we have the floral pattern here. But then I thought to myself, why only be with the trend? Why not just set the trend? And you can basically go crazy with that now and tell it like, yeah, make it twice as trendy. So you get like more flowers. Or basically you can go really crazy with that. When you're like in that loop, it's the same with Wikipedia pages. You just like keep continuing. But then I thought to myself, I actually want to have it more personalized in a way. So what you can do is actually you can tell it to or give it another context vector in that sense to basically, for all of you who don't know the coolest football club in the world, you can tell it like to make it personal for people from Rhineland-Palatinate, and it gives you the coolest Oktoberfest outfit. So okay, then you can feed it into view, and I think you know the story. Then it gets. Do we actually have sound? I don't know.
Ladies and gentlemen, welcome to the show. Tonight we are going to get crazy.
What's cool behind that is every hour, basically, the output changes based on what's trending. So when another plant with a floral pattern basically gets dismissed by whatever kind of pattern, you get like at the model output a new creative image, how you what's gonna look like. So this is how I solved it. So currently I'm trying to find somebody who can stitch this together. So if you're up for it, I would be happy to involve you. Just one thing, because we just heard about bias, I want to just point out that we do, when we run those models, actually try to implement a THIMS ID tag. This can be done obviously in audio and in image, so it's watermarking you can think of that you can actually not recognize as human. We actually do this also for text. This is quite baffling to people, so if you have a large language model that has a specific output, that you can watermark it. The idea is obviously that you can recheck later on whether something has been generated by Google technology. This works actually quite well, so just like keep an eye on if you want to basically get like, for example, an application for a flat, you can check on THIMS ID whether it's been generated for an AI, of an AI. So this is like the the story about the leader was in the other one, and how much time do I have, Thorsten? 5 minutes. I have like 3 more topics. That's great. Okay, now, so I run fast. Okay, run fast. So running is like cool, you know that, right? And I do it all the time. There's that guy who's really, really cool or really, really good in running. And my triathlon trainer, who's called Joachim, he always tells me he has an exceptional running efficiency. And this is true. This guy ran a marathon under 2 hours. He's called Eliud Kipchoge, so one of my idols. And back in the day, we had TensorFlow beforehand, so cool. Shout out to TensorFlow. It's not the most popular library at this point anymore. Nevertheless, a cool model. It has a hub on where you basically can tackle pre-trained models into transfer learning, and one of which is called PoseNet or MoveNet. You might have seen those. They're just dance movie apps or breakdancing or fitness apps where you can count your push-ups. You can use that model in order to analyze Eliud and basically feed in or basically train a benchmark in order to compare yourself against Eliud. We also heard about Allianz from similarity regression function, I think it was. We used something similar here to identify how we compare against Eliud and how to basically become the world champion in running. So what you can do, basically, you can run basically that model from frame to frame. It captures his movement. So frame, how is he moving over time? And how is his posture? How is his left foot, for example, moving towards in relation to his right arm? So you can basically capture that. And he's the GOAT. He's 100%, right? So what I did, basically, I got myself a treadmill. This is no joke. I put myself on the treadmill, and I was basically running the same experiment against Eliud. What came out of it was 70% Eliud. I was actually kind of proud to basically see that number. And I went back to Joachim and told him, dude, I'm 70% Eliud. And he was like, yeah, on these 30%, that's what we are working on. So we got back, and I thought, okay, how can we solve that? I used basically Gemini and threw it in and told him, okay, here's that running model of myself. What can I improve? And Gemini actually told me right away I should use better shoes. My shoes look old and worn out. And this is not a joke. I bought these shoes, and I bought them in every color back then when I was a student because they were cheap and I liked them, but they're not state of the art anymore. So they're really, really old. So this is actually kind of I was actually surprised to see that result because then I figured also that this is the only difference between me and Eliud. No, but jokes aside, this is like the one thing that I can easily change, right? And I can build and I can upgrade the shoe. So I thought, and it was a year back, and it was not quite easy to get Eliud shoes. So I opted for the second best option of shoes I could find. So I got myself flip-flops. I got carbon fiber shoes, and you know those. Maybe if you read any marketing about running, it's like the ones that should give you more propulsion because I have this carbon fiber plate in them. And I basically replicated the experiment once again. So we got the 70% Eliud shoe, we got the flip-flops that I found in my basement, and we got a carbon fiber plate running shoe. And I think you don't even need a machine learning model to see the difference in running styles. But it's actually kind of cool what we did here. We used unstructured material, basically video material. We had a model that extracts key points of your ligaments and of your arms, etc., and basically then can tell towards a benchmark where you're ending up. So in essence, like flip-flops, honestly, that's quite hard to run 20 kilometers an hour on flip-flops. I was actually really proud of myself not to die on that occasion. But what you can see here is like the carbon fiber shoes actually excel quite a bit in running modalities. So that's really cool to see. And I went back to Joachim and said like 76%, and he was telling me, okay, 24% to close. So last shot that I had was like using a diffusion model to change the shoe, to make it faster, better, so that I can fly like a bird. And this was actually when a talk back then when I basically were explaining diffusion models, how you add context vectors in a sort of compression algorithm. So this was, back then it was kind of mind-blowing that you can basically regenerate iterations or associations of other items. And what came out of it is actually kind of surprising because last night I generated that shoe and broke the world record, as you can see here, 200 kilometers an hour on the track. Obviously, it's funny, but think about what we did here. It's like an entire pipeline of for example, video material that we now made sense out of. It's like 1-2 minutes, right? Maybe we're gonna skip AlphaFold then, unfortunately, but I want to show you Genie because Genie 3 is actually kind of mind-blowing in what it can do. So for just a quick raise of hands, who's heard of Genie 3 yet? oh, that's awesome. So at least half of the people, because usually it's quite hidden if you're not like into the area of like the latest models, because there's so much research coming out, not only from Google, from other companies, and a lot of really, really cool stuff. Actually cool to see that a lot of people know about that model. So it's a new model, a new kind of model, and we call it an open world model. And I have difficulty in conveying how really exciting that is for me. But if you think about it, what it can do. So the idea is basically you can usually, similar to a large language model or any other state-of-the-art model at this point out there, you can feed a natural language prompt into it, or you can basically put an image into it, and it generates an open world. So it doesn't generate a video, it generates a world. And this world basically can be generated because the model itself has watched thousands and thousands and thousands of hours of YouTube videos. And from watching those YouTube videos, it actually learned how physics works, for example. And the cool thing is now, okay, we now have an open world. We can interact with that world. So we basically integrated actions that the user, whether it's a gamer or a person using the model later on, can basically do in that open world. So right now the actions are quite limited. You can move around, you can open car doors, you can sit somewhere, or can fall off a cliff, for example. But what really struck me is when you, for example, have like a couple of clips that show you these open world models. So it's just like one prompt as an input, and the person then basically moving around. But what really struck me, there's like, in the blog post, there's one example where a person like put in a picture of the house, like inside, and he was painting the wall on the left-hand side. He was first off, he was looking out of the window, and then he moved to the wall, and he was painting. And what really struck me is like, before he moved left has not existed yet. So it's generated on the fly. And not only can you paint on that wall, whenever you go somewhere, and you know how a model works, it's like millions or billions of parameters. When you turn back to that wall, these actions still persist. So the wall is still painted blue in his scenario. And think about what you can do with that. So just like not only for gaming, it's a huge thing. The main essence why our humanoid robots, even the Google ones, like, to be honest, quite suck at this point, is that we don't have a lot of learning data, or basically a data set that is large enough to give all the degrees of freedom that robots have, the ideal scenario of learning. But when you have a model where you can generate a world, like any artificial world, you can basically generate a whole bunch of data. So this will obviously, in my opinion, also change the robot era in quite some time. Last but not least, and this goes in the direction of it, is also like one model that shows you what a low latency model can do, and it goes in a similar direction.
A basic operating system. There's actually something much cooler. It's a research prototype showing off the capabilities of Gemini 2.5 Flash Lite. Every time you click through to a new window, Gemini is writing the code from the UI and its contents for the very first time, based on the context of the previous screen and the time it takes to click a button. That means this is a non-deterministic operating system. So if we go into this folder and then come out of it, and then go back into it again, the contents are completely different each time. It's not just you can generate whole apps. When you click this icon, Gemini will generate an app based on that context alone. This is an example of something we could only have built with a model like Gemini 2.5 Flash Lite, which is able to process large numbers of tokens in a fraction of a second.
So we built this together with the colleagues from DeepMind. We have no clue what we can use it for, but but just think about the scenario. My parents, they struggle when you move basically one icon to the other side of the desktop. Imagine like everything is newly generated, like every button click. But just gives you, like, it showcases you the power of how quick those models are in understanding your actions and basically generating an output towards that. So I hope this is fairly in time, Torsten. I did my best. For those of you, and this is like, I do like a little bit of advertisement because he doesn't look. We do have like one Gemini Enterprise Hackathon on November 6th, so in our office at Google. So this is limited to 30 engineers. So if you're interested in, you can just apply, and ideally only apply if you want to show up, because as we mentioned, this is quite limited at this point. Put down your company, and then you should be good to go. With that said, I hope I think you had like 3 amazing talks already, 2 maybe. I'm not sure about myself, but the other talks were great. So thanks once again, Thorsten, for the invite, and thanks all you for being here. And now we can, I think, open it up for questions.